When you're trying to solve an equation, it's helpful to think of it in terms of a balance beam, like the one that we have here. Now, this is an extremely basic example of an equation, but it's still an equation because it's got that equal sign in it right there. And it's telling you that x is equal to 6, which in other words means if you were to put on a balance beam an x, it would be perfectly balanced with 6 little boxes. Hence, x is equal to 6. The reason that we know that x is equal to 6 is because it's right here all by itself on this side of the balance beam. The word for something to be by itself that we frequently use in math is the word isolate. That means it's by itself. So the x is isolated on the left-hand side of this equal sign because it's there all by itself. So while our previous example had an x that was isolated, that is by itself, now we have an example of an equation that is not just with an x that is isolated. Because for it to be isolated, it would have to be all by itself. And right now, okay, not only do we have 3 x's instead of just 1, okay, remember that for it to be truly isolated, you can only have just 1 x over there by itself. You can't even have more than one of the same x. So not only do we have 3 x's over here, but we also have 3 units. So it's really hard to see on the balance beam right now exactly how much just 1 x balances out with because there's all this other garbage over here on the balance beam with it. So right now our variable is not isolated. When we are solving an equation, our goal is to get that variable by itself, that is to isolate it. And in the next video, if you need to watch it, you're going to see that we use something called inverse operations in order to be able to get that variable all by itself.